Hey dosers, what's up and welcome back to another video. Today we're going to be focusing on limits to infinity. Yes, so before we covered limits of zero, but today we're going to be doing limits to infinity. So let's get started. So limits at infinity. So we can use the idea of limits to discuss the behavior of functions for extreme values of x. So the extreme value being infinity in this case. So we write x to infinity, meaning x tends to plus infinity, positive infinity for 0 all the way to infinity. That is what this means basically. If it was negative infinity, then it would be 0 to negative infinity. But we are doing, usually it will be to positive infinity. So as x goes to negative infinity, x tends to minus infinity, what I just said. So notice as x goes to infinity, 1 is less than x squared, x cubed, etc. Because if you think about it, 1 stays the same, but infinity means this is larger. But infinity squared is larger than just infinity, and infinity cubed is larger than infinity squared. So as x gets very large, the value of 1 over x, so 1 over x, 1 over infinity would get very, very small because if you think about it, if you do 1 over 1, it's still 1. But if you take larger and larger numbers, the value becomes but it'll still be 0.00001. So that's the kind of logic that we're putting in here. So it says here, in fact, we can make 1 over x as close to 0 as we like by making x large enough. We can imagine the biggest number of x that can happen because infinity is not even a number. It's just that big of a number that we can't even comprehend it. So we can make x as large as we want, and this means that x is so large that the value is basically 0. Like the value tends to 0. It goes so large to 0. Like there's so many zeros before 1. Like there's so many of these guys. So many of these before it actually reaches 1 over here. So like it basically is 0. That's what the rule implies in this case. So even though 1 over x actually never reaches 0 because it will always have, no matter how many zeros there will be over here, there'll be way more zeros over here, but there'll always be this 1. So it's never actually 0, but we can take it as 0 is what the limit implies. So you can see both of those cases over here. I'm not going to go through that, but this is the most important part. Usually the definition isn't the most important, but in this case it is. It'll make more sense once I do this question over here. So we have an actual function now, and it says limit to infinity of 2x plus 3 over x minus 4. So how are we going to do this? Let's see. So if we take infinity minus 4, so if we just try first off in plugging in infinity, what does that do for us? Well, 2 times infinity plus 3 over infinity minus 4. Now where would we move from this? We cannot do anything. Infinity has no value, so we cannot multiply it by 2 and add 3. And infinity minus 4 we do not know the value for. So this case, we cannot do this right now. So the usual case that we can do in this case is what we usually do is try to eliminate an x. We try to remove this guy over here. We try to remove him and we try to solve the equation from there. Usually we try to remove him from the numerator but leave him in the denominator. But in this case, this question is a little different. So we're still going to do the same thing. We're going to remove an x. So we remove an x from this equation plus 3 over x. As if you multiply x over here, it becomes 3. And we do the same in the denominator, so 1 minus 4 over x. Now in this case, we see clearly we can cancel out these two. And what do we get? We got 2 plus 3x, 3 over x, sorry, over 1 minus 4 over x. And that is our equation right now. Now you must be wondering, what does that do? The x is still there, like how are we going to proceed from here? Well, in this case, once we try again to plug in infinity, we get 2 plus 3 over infinity over 1 minus 4 over infinity. Now, infinity, like we said over here, it doesn't have to be 1 in this case. It can be any number. But infinity is so large in this case that any number that is given at the top tends to 0. So in this case, 3 over infinity will tend to 0. The same as 4 over infinity will tend to 0. It'll never actually be 0, but the rule states that you can infer that it tends to 0 because infinity is just that big. So what we get in this case is you get 2 plus 0 over 1 minus 0. So you get 2 over 1, which is just 2. Bam. That is your limit to infinity. That's how you do the limits to infinity. So now I want you to have a go at this question as your own homework, home learning, whatever you want to call it. But have a go at this question and let me know how it goes. The mark scheme is on the next slide of these Canva slides, which will be in the description below, along with a tutoring link, one-on-one tutoring with me, completely for free, half an hour, whenever you do want to book it. Obviously, the times will be a little bit more constrained now as summer is coming to an end, but still go ahead and book that for whenever I'm free. So thank you very much for watching today's video. Take care and have a good one.